Okay, so factoring a quadratic polynomial with leading coefficient only 1, as in 1 times z squared, or 1 times x squared, or whatever the variable is. So we're going to learn another method soon enough, and that method will cover this scenario. But when the leading coefficient is only 1, it's usually not too bad to do it, just kind of winging it, which is what we're going to do. Now, when we factor it, we're going to have a binomial times a binomial, right? Now, it turns out that the first term in each binomial, those two guys need to multiply to this first term. Well, that's easy to remember. The firsts multiply to the first. So the only way that's going to happen is z and z, because it's just z squared. Now, if it was like 12z squared, then it might be, wow, is it z and 12z? Or is it 2z and 6z? Or is it 3z and 4z? And so then it becomes a bit trickier because you got a lot more options. Okay, now the last term in both binomials, they need to multiply to this last term. Okay, always. So we could do 1 and 26 or 2 and 13. Now it turns out that they need to not only multiply to positive 26, so have the same sign, but they need to add up to the middle number, negative 15. Well, if they're going to multiply to a positive and add up to a negative, the only way that can happen is if they're both negative. And it turns out 1 and 26 is not going to work, but 2 and 13, that'll multiply. Negative 2 and negative 13, that'll multiply to positive 26, and will also add up to negative 15. And now it's done. And that is kind of how you do them with what I call the shortcut. Let's do one more of those. Once again, the firsts have to both be z. Okay, and the lasts have to multiply to negative 10, which means one has to be positive, one negative. But they're going to add up to a positive 3. Well, I could do 10 and 1 or 2 and 5. If I do positive 5 and minus 2, that'll multiply to negative 10, but will also add up to positive 3. Now let's multiply to negative 10, add it to positive 3. And so, these actually do get kind of fast once you get the hang of it. Now on this, where there's more than one variable, all we're going to do is just temporarily pretend that that second variable isn't even there. Okay? Just ignore the y's. All right, so then just temporarily, don't forget to bring them in at the end. And then we're going to say, all right, well, I'm going to factor this, and well, we already know it's x plus 5, x minus 2. Okay, and then now that it's factored, all you got to do is slap those y's in at the end of both. That's where you put them, right there. Boom. And if you multiply it all back out, you'll get back to where you started. So that's what you do. When that second variable is there and you're factoring with this method, just pretend the second variable isn't there just for a few moments, then put it in at the end. Okay, now this one, the leading coefficient is not 1. The leading coefficient is 6. Is this recording? Okay, it is. But what you always try when factoring, first factoring method you always try is greatest common factor. And there is a greatest common factor, and it's 6. I can pull a 6 out of each term. Okay. Now the leading coefficient is 1, and so I can do that factoring that we've been practicing. So they both got to be a v, and then I need a pair of numbers right there that multiply to negative 4 and add up to positive 3. How about 4 and minus 1? That'll work. And then now the polynomial is completely factored. So you have to first pull out the GCF on this topic.